Okay, so we've been looking at some units for speed, and we agreed that in all different cases, the units for speed always involved a distance and a time. And we said that we always had unit of distance divided by a unit for time, because it was meters per second or kilometers per hour. So that gives us the idea that speed is equal to distance divided by time. This is probably an equation you're relatively familiar with already. We've got speed is distance divided by time. Now, we're going to be writing this out a lot, so we don't want to write out the whole words each time. So we shorten this to S for speed is equal to D for distance divided by T for time. That just makes it a bit quicker to write out. So S is D divided by T. Speed is distance divided by time. Now, in some calculation questions, you will be asked to find the speed. In some calculation questions, you may be asked to find the distance or the time, and so you'll have to rearrange this equation. We'll have a look at that now when we look at some examples. We have a particular way we want you to lay out your calculations in physics, and this is following the procedure wires up. So you can see this on the right hand side. It's probably a good idea at this point to pause the video and make sure you have this clearly written down in a large box in your book, because we're going to be coming back to this very, very frequently with calculations. So if you've unpaused the video now, you should have all this written down in your book. We can see what it says. When doing calculations, W. The first thing, write out the equation. I is insert the numbers. R is rearrange if we need to. E is evaluate. That means do the calculation, get your calculator if you need it to find the answer. S, check you have the correct numbers and become figures. U, make sure you put the unit on the end, as it meters per second, for example. And P, just think, is it plausible? Am I trying to say a car is travelling at 0.001 meters per second? Because that's probably not realistic, is it? So it's just a plausibility check, that last one. So we've got wires up. So let's have a look at an example. Let's imagine we have something that travels 120 meters in 30 seconds. So we have an object that travels 120 meters in 30 seconds, and we need to find the speed. So the question is, find S, find the speed. So following our wires up procedure, W, we write out the equation. S is equal to D over T. I, we insert the numbers. So what do we got? S is what we're finding. So the S goes underneath there. The equal sign lines up on the line underneath like that. The equal signs line up. D, we've got a distance of 120 meters. And T, time is 30 seconds. So we put that in there. The equation already says S equals, we're trying to find S, so we don't need to rearrange it. So we evaluate it, get our calculators if we need to. I think this one we can probably manage. Equal signs line up like that. We managed to get that as 4. Significant figures. So in a lot of cases, you'll end up with answers that are recurring decimals or have a lot of further significant figures. And we want to make sure we round those to the same number we're given in the question. So here, 120 is potentially 3 significant figures. 30 is potentially 2 significant figures. So I'm going to give this answer to 2 significant figures. So 4.0, I'm going to say. And then the units. Well, we divided something in meters by something in seconds. So that's going to be meters per second. And is 4 meters per second a plausible speed? Yes, I think it is. We'll have a look at some further examples in the next